proposed 50-kilometre tunnel between the United Kingdom and France. In fact, it comprises 3 tunnels. A similar running tunnel to the one shown here, but running in the opposite direction. Both running tunnels separated by a service tunnel. A number of shuttles will transverse the tunnel, a journey time of 30 minutes. Vehicles will drive on, drive off, and Eurotunnel have opted for a policy of non-segregation, whereby passengers remain in or with their vehicles for the duration of the journey. The problem here is how to prevent a fire situation in a shuttle wagon becoming a catastrophe in the tunnel. A possible solution is the use of water sprays aboard the rolling stock. As we were unable to conduct fire tests at the Sunbury Research Centre, we established a facility at the fire ground on the perimeter of the BP refinery Grangemouth in Scotland. The test bed comprises a modified shipping container, fire hardened and well instrumented. Although somewhat rough and ready in appearance, it is very functional in practice. Of particular interest to Eurotunnel is the suppression of gasoline fires. 8 litres of gasoline is placed in a tray of 1 square metre cross-section, surrounded by an overspill tray. Some 2 metres above the fire tray are 4 nozzles, positioned in a square configuration. On the next video clip, you will see the nozzles activated 30 seconds after gasoline ignition. At that time, temperatures of 800 to 900 degrees centigrade are measured close to the fire. Within seconds of the spray reaching the fire tray, the fire is extinguished. Water consumption is less than 1.5 litres. Within 10 seconds of extinction, temperatures are knocked down to ambient and will return to an almost smoke-free environment with excellent visibility. Another scenario of interest to Eurotunnel is the under-vehicle gasoline fire. Again, we used the Grangemouth container, and to simulate this situation, we constructed a sheet metal mock-up of a car, under which we locate the fire tray containing 8 litres of gasoline. 2 cases have been investigated, doors open and doors closed. Here the fires will be attacked by 4 side-mounted nozzles. The gasoline is ignited, and with the container doors open, the flames are fanned by a 20-mile-per-hour headwind, very similar to the draft generated in the tunnel from the train's piston effect. On the 30th second, the sprays are turned on, and the intense fire is extinguished almost instantaneously. The experiment is repeated, but now with the doors shut. Shortly, on the right-hand side, you will see water trickling from the nozzle just prior to the introduction of air. On average, it took less than 4 seconds to extinguish all under-vehicle fires, consuming less than 1.5 litres of water. Smoke suppression, temperature and radiation knockdown are very effective, providing a survivable atmosphere within 5 seconds of fire extinguishment.